Dear students, today I shall discuss about the second semester engineering mathematics, that is module 4. This time we have the new code from VTU, that is 17 Mat 21 engineering maths second, and today I shall discuss on the integral calculus which comes in the module 4. This consists of the discussion on double and triple integrals. Sorry. In that, the further contents are evaluation of double integral and triple integral, evaluation of double integral by changing the order of integration, evaluation of double integral by changing into polar coordinates, application of double integral to find the area and volume, applications of triple integral to find the volume, and it will be both of these cases will be followed by problems. And the next topic connected to this integral calculus is beta gamma functions. These are special integrals which we use in engineering applications where we cannot solve the integrations by the analytical methods. Then we go for a directly use of these integral equations, that is, one is beta function and the another one is gamma function. In this beta function we use the limit as 0 to 1, and in the gamma function we use the limit maximum, that is 0 to infinity. In that, sub contents are definitions of these two symbols, that is beta and gamma functions, and the relation which is very important which connects between beta and gamma functions, that is relation between beta and gamma functions, and the problems will be followed by the definition and the properties and the relation between beta and gamma functions. In this, evaluation of double and triple integrals today I shall discuss, and evaluation of double integral by changing the order of integration. I shall discuss in detail about these topics. It goes like this. Already you know the integration with single integration, and we are going to extend the discussion on double and triple integrals, where we come across these single integral, double integral and triple integral. In which situation we come across? A single integration deals with function of single independent variable, and double integral deals with function of two independent variables, and triple integral deals with function of three independent variables. And in this single integration we assign the limits as x equal to a and x equal to b, that is between lower limit and the upper limit. We call those two boundaries. Dear students, as all of you know that what is the meaning of integration? That is, integration is denoted by I equal to integral a to b fx dx, which conveys the meaning. We find the area of the function, that is fx, which appears under the integral sign, which is represented by the dependent variable y equal to fx, and it is covered between two boundaries, that is lower limit and the upper limit. The basic meaning of this integration is to find the area of the curve that is drawn by the equation, that is y equal to f of x, between lower limit and the upper limit. And the meaning is extended. There we consider other coordinates like y and z as constants, but here in the double integral two variables we consider, and integration will be done first with respect to one symbol, that means with respect to one variable, and another integral we call it as outermost integral. The earlier one we call it as innermost integral. These two integrals successively we do that by assigning once both the set of limits as constant limits, lower limits and upper limits, and another situation also we will come across. Innermost integral may contain the limits as variable limits, and the outermost integral will contain the must contain the limits as constant limits. And the same performance will be extended for the evaluation of this triple integral in the same order, that is one more variable we are going to include, that is by means of z. Therefore, in that triple integral, x comma y comma z will act as three variables, that means innermost integral one symbol, its adjacent integral with another symbol, and outermost integral obviously it will contain the constant limits. Then here on the case of double integral, we deal with problems, basic problems. In that I will discuss about the integral problems, that is problems with constant limits and problems with variable limits. Evaluation of double integral by changing into polar coordinates, and evaluation of double integral by changing the order of integration. That means changing the order of integration, why we study, and changing into polar coordinates, why we study. Let us start with evaluation of double integral. It goes the applications also, the double integral and triple integral. As you have seen, single integral, that is y equal to fx under the integral sign carrying the limits as x1 and x2, and that went for application, that we studied for the application of area, volume, surface area and the length. We call it as rectification. Likewise, here also we study, as per VTU revised syllabus, we study here the area and volume by applying double integral, and we study only the volume by the triple integral. Dear students, please remember, this is 17 Mat 21. In this 17 Mat 21, you must read the syllabus, you go through the syllabus very specifically, and see that you can prepare accordingly for the exam. That is one aspect. But another aspect is the knowledge required from this integral calculus is very important for the engineering point of view, because the calculus plays a major role in the engineering applications, as all of you know that. So that you need to know what is happening in differentiation, what is happening in differential equations, what is happening in integration basic, and what is happening using these integrals as applications. Therefore, you must be completely aware, irrespective of any branch, you must be completely aware of these basic concepts, basic formulations. Then let us start with the introduction of double integral. Here I consider for my convenient discussion, that is function which contains two variables, that is f of x y, be a continuous and single valued function of x and y within the region R and bounded by the closed curve upon the boundary C. Here we consider this region is subdivided into many other regions, and will denote them as delta A1, delta A2, delta likewise delta AN, the total area. In the next 1 or 2 slides I will show the figure. In that figure sub-regions I will explain. Now we assign some other notations to be a point in the sub-region in the area. For example, the first sub-region like xi and n, that is xi I and eta, that looks like n, but it is eta. And likewise I is equal to 1, 2, 3, we assign all the values, and we will see that what is the area in the subdivided regions. Then it will be symbolized and it will be denoted by double integral f of x y dA, that is covering in the total region. Therefore, integration will be expressed in terms of the sigma notation following the limit. Therefore, double integration f of x y dA is equal to limit of sigma f of xi I eta j and then delta ai, then n tends to infinity. That means sub-regions we give. Then region R being is called region of integration, and this corresponds to the interval of integration, that is a comma b in the case of definite integral. In order to simplify the evaluation of double integral, we consider sub-regions Ri, and one common choice is the rectangular sub-region and the rectangular grid obtained by subdividing R by lines parallel to the coordinate axis as shown in this figure. These are the sub-regions in the total domain. This is the domain actually, and this delta xi is the displacement and delta yi is the displacement respectively on the x-axis and y-axis. So that inside this area so many sub-regions are there, and every region in terms of individual area we calculate. by means of integration. Now, the same integration will be considered double integral here, that is area of the rectangle is given by the above integral which is already shown, and the integral double integral is represented or can be assigned by two types of limits as I mentioned earlier. One type of limits in the case of double integral which will carry the double integral with constant limits, and another case as variable limits. Now, the case is constant limits. For example, this is the innermost integral, double integral f of x y dx dy is equal to double integral f of x y dx dy, means first I consider this one with limits. So, this is without limits you assume, and this is with limits you assume. So, let me propose the constant limits as innermost integral, that is y equal to c and y equal to d. Both c and d are constants as lower limit and upper limits respectively. That means y equal to c we assign for innermost integral as lower limit, and y is equal to d we assign the upper limit for the innermost integration. And similarly, another integral for the outermost integral we assign x equal to a and x equal to b respectively, as once again as I mentioned earlier, that is lower limit and the upper limit. Similarly, you will see another type of discussion in the double integral. This same double integral will be taking on the right side with the type of limits. This innermost integral we call it as this one, this integration f of x y dx. So, this will be covering the discussion on x equal to gy and x equal to hy. What do you mean by these two representations? That means these two representations will convey the meaning this x1 and x2 they are not constant limits, but they are variable limits. Then x is a function of y and g is a function of y. These two limits will be assigned for this innermost integral, and the outermost integral y equal to c and y equal to d will act as constant limits as lower limit and the upper limit. Next is the basic information so far I discussed, and I will go to the examples, simple examples on all these cases. That means double integral evaluation with constant limits and double integral evaluation with variable limits, and later the double integration by changing the order of integration and double integration by introducing the standard polar coordinates. Let me take a simple example here. Evaluate the double integral in double integral x square plus y square dx dy. Now, let me start with a single integration in order to convey the meaning that integration what kind of limits you are going to assign. In my discussion I will mention like this: a to b x fx dx and a to b c to d f of x y dx dy, a to b c to d e to f of x comma y comma z dx dy dz. This already you are much familiar. Now, in the engineering applications you have to study these two. General problems on this, and changing the order of integration on this, changing into polar coordinates on this, and after the general problems in the triple integral you have to study the how the volume calculation goes. Now, the first example let me take double integral x square plus y square dx dy, and the outermost integral that is taking as 0 to 2, and the innermost integral that is between 1 to 2. The example, how the concept goes: evaluate double integral 0 to 2 and 1 to 2 x square plus y square dx dy. You can remember that these two limits in as lower limits and these two limits as upper limits, both of them are constants. Both of them are constants means you can take the same order as dx first and dy next. Otherwise, even the constant limits that is immaterial where dx appears first or dy appears first, because constant limits we can take in any order and then you can take the integration. Your discussion in the main syllabus of 17 Mat 21 starts with this type of problems: evaluation of double integral, general problems that presently I am doing. This is one such case as with constant limits. Okay. We have to as a formality we have to represent this by means of integral symbol, that is I is equal to 0 to 2, 1 to 2 x square plus y square. Here I will take like this, then dx, close the bracket, and it is dy. What do you mean by this? That means this is innermost integral and the adjacent one is outermost integral. You cannot evaluate or you cannot integrate between 0 to 2 with respect to y first and then innermost integral, because the application meaning goes like this. For double integral and triple integral, this is we take small subregion in the main domain, that is R, like this. According to this integral problem, that is 1 to 2 x square plus y square and it is dx. Then your adjacent integral, that is 0 to 2 and then it is dy. That means this is called innermost integral and this is called outermost integral. This is similar to one word which you are using in programming subject, that is hierarchy. Hierarchy method means innermost parenthesis evaluation should be taken first, then its adjacent, then its adjacent. Exactly, but you cannot change, you cannot evaluate the outermost integral first and then innermost integral. That means this is to be evaluated first. Accordingly, I put the bracket like this. Therefore, you have to integrate with the usual meaning. Therefore, 0 to 2 keep it as it is and the integration. Now, you are doing the integration with respect to x. That means this is 1 equal to x and 2 is equal to x and 0 is equal to y and y is equal to 2. That means you are giving the limits for x, lower limit as 1 and for x 2. That means you are integrating with respect to x. This is nothing but even another symbol also you can give, x1 x2, that is y1 y2, like that also. When once you understand the meaning of this writing formulation, and you will be so perfect in handling these things inside the square brackets and adjacent the square bracket. Okay. This you have to integrate with respect to x. That means you have to keep y constant when you are doing the integration with respect to x. This is exactly what you learnt in previous semester, that is partial differentiation. What do you mean by partial differentiation? Partial differentiation which you have understood as when you are differentiating with respect to selected symbol, at that time rest of all the symbols will be taken temporarily as constants. Exactly same meaning you are applying. Now, you are doing integration with respect to x, keep y as constant. Yes, let me proceed with this, that is x cube by 3 with respect to x, and here y square happens to be the constant, then y into x, because y square into dx gives us integration this one. Now, you are going to replace the limits x equal to 1 and x equal to 2, then dy as it is. Therefore, this is 0 to 2, then put x equal to 2 here, that is 8 by 3 plus of x equal to 2, it is 2y square, and when you are applying the lower limit, minus sign you have to assign, that should be 1 by 3 and minus y square, close the bracket, and then it is dy. Here double integral is reduced to the single integral. Now we can proceed to the next step. For example, if any simplification is possible, you can do it. There itself you can reduce the number of terms and then one by one terms you can evaluate. Now, for example, these two are the constants and these two are having the same degree. You just simplify it, that is 0 to 2, and 3 happens to be the LCM, common LCM, and it gives the simplification, that is 7 by 3, and 2y square minus y square is minus of y square. What is your conclusion at this stage? First stage, 2 variables, one variable you took for integration, you have eliminated by putting the limits. Now you are finally left with single integration. You have to do this integration with respect to y. This is 7 by 3 into y, because there is no y, then dy means y integration and y cube by 3 here. Then you will replace the limits, that is between 0 to 2. Therefore, put y is equal to 2 and then put y equal to 0. You have to do the simplifications, that is 7 by 3 into 2 minus 8 by 3. Obviously, for both the limits when y equal to 0, that becomes 0. Here 3 is the common LCM, 14 by 3 minus 8 by 3. Therefore, 6 by 3 is the answer. If you take like this, then if you choose the same double integral in another type, your answer will be according to those selected limits you will be getting. Let me take another example. Let me take another example, that is 0 to 1 and 0 to 6 x y. Zero to 1, 0 to 6 x y. This let me take also dx. In whichever the order it is given, you just go according to that. Now, let I is equal to, same notation you have to assign, 0 to 6 x y dx dy. Put the brackets again for this. Then this is for x inside, x equal to 0 and x equal to 6, and outermost integral y equal to 0 and y equal to 1. Directly you take the integration with respect to x. Therefore, x square by 2 into y, where x equal to 0 and x equal to 6, and then it is dy. 0 to 1 x equal to 6, that is 36 by 2, and y minus x equal to 0. Second term won't exist at all. Then it should be dy. So, double integral reduces to the single integration, that is 0 to 1, 0 to 1, 36 by 2, that is 18 into y, it is dy. Now, with respect to y, you can integrate, it should be y square by 2. Then you have to assign, apply the limits, that is 0 to 1 only for this single variable. Therefore, 18 by 2 into 1, answer is, that is equal to 9. Similarly, I will go for another example. This is also similar type integration with constant limits, that is 0 to b and 0 to a, both of them are constants. You can do in the similar way the calculation of the integration. Now, let me take another situation. Opposite type of this discussion is limits of the integrations are not constants, but they are variables. This is very important situation. Now, the example is 0 to 1 and 0 to root of 1 minus y square and x cube y should be dx and dy. The first case like this problems which I discussed as two simple cases, maybe very rarely you will come across constant limits, but you need to concentrate more on this type of calculations. This is innermost integral carries the limits not as constants, but as function of variable, and outermost integral 0 to 1. Now, you cannot go as you wish the order of writing the integration. You must remember the according to the theory, how we have to proceed further means which symbol appears first, go for the integration with respect to the opposite symbol. That means, you cannot do the integration with respect to the same. The reason is this is 0, this is 0. Let me start with solution with by assigning the same symbol. Let I is equal to 0 to 1 and the integration 0 to root of 1 minus y square and then x cube y. I must put for this as dx, close the bracket, and then dy. Now, this is the case as the application. Here this is 0 to 1 and 0 to root of 1 minus y square. Here it is a must that you have to go for opposite symbol for the innermost integral. That means it is a function of y. How we are going to represent? Function of y means in the theory already I said that is this one. This is x is g of y and x is h of y. In this integral, exactly you compare these two symbols with the present problem. That means, here x equal to 0 and x equal to square root of 1 minus y square. That means, in the case of innermost integral, this will take x is a function of means f is already used, g of y and h of y. It is a function of y. So, this if this is lower limit, but according to the given problem this is equal to 0. That means, lower limit is 0. According to the given problem, h of y is equal to square root of 1 minus y square. That means, x is a function of y, lower limit, coincidentally it is 0, and x is the upper limit function of y. Now, you have to integrate only with respect to x, then keep y as constant, so that your integration gives 0 to 1, and here x cube with respect to x means x to the power of 4 divided by 4, keep y as constant, and you are going to apply only for x equal to 0 and x equal to square root of 1 minus y square, and then it is dy. Therefore, through this, what do you understand? Through this, you are going to eliminate one symbol and you are going to retain another symbol for the single integration. You had from the given problem two symbols. One was for the innermost integral and the other one is for outermost integral. But in the previous two problems we came across both the symbols were representing the limits as constants, but here in this integration one set of limits as variables and another set of variables as constants. So, you have to handle very carefully for the variable in the case of variable limits, then applying the limits with this upper limit and lower limit, that is 0 to 1 1 by 4 I will keep outside, and also y I will keep outside. I have to apply the limits for this. Then x to the power of 4 is this one, 1 minus y square whole to the power of 4 by 2, like this, because this is to the power half, and applying half to the power 4 means 4 by 2. This must be dy. Then 1 by 4 integration 0 to 1, this is y, and here 2 cancels, that is whole square. 1 minus y square should be whole square should be with respect to dy. You have to do the integration with the ordinary method. Ordinary method means here take y inside and expand it, and each term you must integrate. That goes like this: 1 by 4, that is 0 to 1, multiplied by, this is 1 minus y square whole square, just like a minus b whole square you can expand, that is y square, minus 2y square means 2y cube when I took this y inside, and plus of y square whole square, it will be y to the power of 4, and multiplied by one more y from outside, it makes us y to the power of 4 plus 1, it is y to the power of 5. Then this has to be integrated with respect to y, that gives 1 by 4 multiplied by y cube by 3 minus 2 times y to the power of 4 by 4 and minus y to the power 6 by 6, and then it is between 0 to plus 1. Wherever y is there, you replace this y by plus 1, that is 1 by 4 and multiplied by 1 by 3 minus 2 into 1 by 4, 1 by 6, that is the end of it. Therefore, this will be 2, then 1 by 4, 1 by 3, 1 by 2 with minus, and minus 1 by 6. Maybe 6 will be the LCM, 1 by 4, obviously 6 will be the LCM, 3 2s are 6, minus 2 3s are 6, and minus 1. Therefore, minus 3 minus 1 4 and minus 2 by 6. So, this is equal to minus 2 divided by 4 into 6, 2 that is minus 1 by 12 is your answer. This is the integration with variable limits. This is one such example. Let me discuss another one in the same type of one set of limits as variables and another set of limits as constants. Normally we come across the functions under the integral sign like this, polynomial terms, and the next one which I am going to solve as exponential. Even you will get the term as log function. Any function you will come across, but you must be very careful when variable limits are given. Let me go for solution of another example. Here this double integration takes the limits 0 to 2 and 0 to x square, 0 to 2, 0 to x square e to the power y by x, and it must be dy dx. Here I try to draw your attention that previous problem when you solved, it was dx dy, but now it is dy dx. Can you say why it is taken like this? Because innermost integral carry the limits, upper limit as x. Therefore, at least one limit out of 2 are both the limits, lower and upper. Okay? If those limits are not clearly constants, then at least one appears as variable, then you cannot take the order of the integration as you wish. You cannot take. You have to go for opposite type. X is there, you must choose y. Even if it is given as dx, you must rewrite the problem. For example, if they give like this, even in the question papers also you must be very careful. Sometimes student needs to rewrite the problem, especially in double and triple integrals. questions will be set even of that type also. You must see the old question papers, you will see that sometimes people expect the student has to rewrite the problem according to the basic first step, and then you have to proceed for the solution. For example, if it is given dx dy, then immediately you do not write in your answer book like problem is wrong or data is wrong. Especially in this chapter, you need to rewrite the problem according to the given limits. You have to reset the problem, then you have to start which one you have to do the first integration and which one you are going to conclude it. Therefore, x is there, you cannot do that with respect to x, even if it is given with respect to x, then you need to change compulsorily before going to the next step. Therefore, your integration, let I is equal to 0 to 2 and put the bracket, put inside 0 to x square e to the power y by x should be with respect to dy, and then it is dx. Now you integrate exponential term. This is the ratio as y by x. In this ratio as y by x means you have to consider very carefully your variable is y but not x. I repeat this, your variable for the integration for innermost part is y but not x. Therefore, 0 to 2 should be with respect to y means e to the power y by x and divided by 1 by x, and this will be under the limits as 0 to x square and dx. Apply the limits. 0 to 2 x into this is x square by x and minus, that is also x multiplied e to the power 0 is 1, that is 1. Therefore, it is dx. Now you are finally left with x into e to the power x minus x and it is dx. Now you integrate the first term by integration by parts. You need to recall the formula which you studied even in right from 12th standard you studied, that is in the case of integration by parts. So, this is a product, directly no formula is available, you have to do this by part, and in the integration by parts, which term you are going to select as first term and which term you are going to select as second term, and why you are selecting first term as algebraic term and this is exponential term. Okay, this is variable x, you have to select first term because on differentiation this must be vanished. Therefore, this is first and this is second. Therefore, it should be x into e to the power x. The formula says first into integral of second minus integral of differential of first into integration of second. That is your fundamental formula. First into integral of second e to the power of x is same minus integral of differential of x is 1 into twice, directly I am writing twice integration of e to the power of x is this one minus x square by 2. Therefore, these terms will be defined between 0 to 2. Then you have to consider the upper limit 2 into e to the power 2 minus e to the power 2 minus 4 by 2. This is your answer. Therefore, e square minus 2. This is the final answer. So, like this problems will be there, and another situation directly. Sometimes you will be given not the problem directly with limits, but sometimes with some explanation they will give. That explanation goes like this: to evaluate the double integral by considering the intersection of two curves. That is a special example which I am writing, and you will find the problems of various types and try to concentrate the application meaning of every problem. Application meaning, for example, in the first 1 or 2 cases which we discussed as constant limits, and next 1 or 2 cases we discussed as combination of constant and variable limits. And the third possibility is very important. Now, in this third possibility, we consider intersection of two curves the problem will not be given in the form of symbols, but problem will be given in the form of statement. That statement goes like this: evaluate the double integral, that is evaluate the double integral x square y plus x into y square plus x into y square should be dx dy. It is given like this over the region bounded by the curves, over the region bounded by the curves y equal to x and y equal to x square. In many of the engineering applications, engineering situations, you will come across the intersection of the curves. Obviously, this is a linear curve and this is a non-linear curve, y equal to x square. So, your double integral is without limits in the present problem. You have to assign proper limits looking to the given type of statement. That application of limits will go like this according to the given problem. Let me mention I equal to integration double, that is x square y plus x into y square and dx first and then dy, dx first and then dy. That means, let me treat according to this existing situation itself, because these things you will come across in many situations where the intersection of curves which will happen. I equal to, that is x square y plus x into y square dx first and dy next. I will put the bracket like this. Now, when I put the bracket like this means, let me take a chance of assigning this dx according to the previous problem. X will take variable limits and let me allow this y to take constant limits. How we are going to assign the constant limits and variable limits? That is only possible when you plot the rough graph of this, then you can analyze how the limits you can assign. That must be very clear to you, what kind of these equations, because these equations are already familiar to you. What is the first equation? This is straight line, and second equation is what? Equation of the parabola. Okay, let me plot that first, then you will come to know what is the area which you are going to discuss by means of double integral, how that area lies as the intersected part between straight line and the parabola. Straight line means y is equal to x. What kind of equation it is? It is a homogeneous equation. That homogeneous equation plot, that means a straight line passes through the origin. Let me write, this is the origin O, this is y and this is x. Then the straight line goes like this. This is y is equal to x. Already you know that y is equal to minus x, that goes to the third quadrant and the fourth quadrant. This is in the case of first and second quadrant and fourth quadrant for y is equal to minus x, but y is equal to plus x will be first and third quadrants. Now, y equal to x square, that should be the parabola. That parabola focus lies on the x axis, y axis. This, somewhere here the focus comes, because the equation which you studied in first semester engineering mathematics syllabus, applications of integration. Applications of integration means, in any given equation, if the equation contains even powers of x and odd powers of y, the curve is symmetric about the y axis, but not on the x axis. Curve is symmetric about the y axis means this region and this region. That is, on the y axis, on either sides the area is same. We call it as symmetric with respect to the vertical line, symmetric with respect to the y axis. Now, the intersected part between this is y equal to x square, this is a parabola, and this is straight line. The intersection between these two curves is this part. You have to do this by means of double integration, should be x square y plus x into y square, and then it is dx dy. But you cannot proceed unless you assign proper limits. How do you collect the limits for these things? You will collect the limits according to the given information. Now, you have to assign for outermost integral where is y1 and y2 according to the order, and this is x1 and x2. Easily you can make out here dx is the innermost integration derivative, so that you have to assign x1 is a function of y and x2 is also a function of y. In that fashion you have to assign the limits. Okay, what is x1 and x2? Easily you can collect from these two equations. Y equal to x and y is equal to x square. These two will imply, in the reverse order you write x equal to y, and this one x equal to plus minus root of y. We cannot assign negative because your area lies in, this is first quadrant, second quadrant, third quadrant, and this is fourth quadrant. But your area lies in first quadrant where positive, because both plus, so that we will drop this negative sign. Thereby x equal to y and x equal to root y. X equal to y and x equal to root y will be the limits for innermost integration, and for outermost integration we have, you have to collect the limits for outermost integration means point of intersection you have to take. What is that point of intersection? Capital A contains what limits? How to collect the limits? You solve by the given equations. How to collect it? Y equal to x and y is equal to x square imply that is x equal to x square. You can easily compare RHS of the first equation with RHS of the second equation. Then x square means x into x minus 1, easily you can write by taking common x, that is equal to 0. Then x will be taken as 0 and x will be taken as 1. Therefore, obviously at the origin x equal to 0 and y is equal to 0. That means origin takes the coordinates as 0, 0, and at x equal to 1, put in any one of these equations, you will be getting y is also 1. Therefore, here A will be the, we will have the coordinates 1, 1. A will have the coordinates 1, 1. Therefore, integral you would have written like, 0 to 1 and 0 to 1. This is fine, final. This is the end of the solution. But we, according to the given problem, let us assign x is equal to root y and x equal to root y. Therefore, I is equal to 0 to 1 and y to root y, x square y plus x into y square, then it is dx, close the bracket, and then it is dy. I hope you will proceed from here. This part is to be integrated with respect to x and put the limits, you will get the answer. Then x is eliminated, and finally you do the integration with respect to y. Thereby you will get the answer. This is application problem. Like this the things will go, and you can repeat the problems for all other applications in the form of statements. In the next discussion I will continue from this problem onwards. If you have any questions, you can ask regarding this syllabus, I will answer.